Guys, what's up? Today we're looking at solving a linear differential equation using the integrating factor. And the differential equation is y prime plus 2xy equals x cubed. And I just wrote out the general strategy that we have over here. The general strategy normally is just to compute the integrating factor, multiply the whole differential equation by the integrating factor, undo the product rule, integrate both sides with respect to whatever variables left. Don't forget your plus c, solve for the, in this case we're going to solve for y. Use the initial condition if you're given one. We don't have one here, so we're not going to have to worry about that. So first thing we want to do is solve for the integrating factor. So what is the integrating factor? And that is going to be, so IF, going to be e to the integral of p of x. In this case, that's 2x dx. So don't forget p of x is right here. So this is p of x. Integrating factor is e to the integral p of x dx. So integrate that, we get e to the x squared, so that's our integrating factor. Now multiply the whole equation by e to the x squared, we get e to the x squared times y prime plus 2x e to the x squared y equals x cubed e to the x squared. On the left, we undo the product rule, we get d by dx of always integrating factor e to the x squared times, in this case, y equals x cubed e to the x squared. So we undid the product rule on the left, right-hand side is unchanged. Now what we want to do on both sides is integrate with respect to x. So integrate with respect to x. And on the left, we get e to the x squared y equals integral of x cubed e to the x squared dx. Now what we're going to do to solve this integral is a w substitution. I'm going to use w because you'll see why in a minute, but I'm going to use w equals x squared, and dw equals 2x dx. So this is going to be integral. Well, if I take one of the x's from here and move it over to the dx, that'll give me dw over 2. So dw over 2, if I take one of these x terms and move it over to the dx. So basically I'm splitting that up into x squared times e to the x squared times x dx. So x dx is just dw over 2. And now I have w e to the w. So w e to the w. And that requires integration by parts. So u equals w and dv equals e to the w dw. And then du is dw, v is e to the w. And this is going to become, let's see, w e to the w minus integral e to the w dw, which will be w e to the w minus e to the w, which, if we turn that back into x's, is going to be x squared e to the x squared minus e to the x squared plus c. And now that's what e to the x squared y is supposed to be. So e to the x squared y is supposed to be this, which means y, we solve for y, we get y equals x squared minus 1 plus c e to the negative x squared. And that would be our solution. Now we don't have an initial condition, so we don't solve for c. But there is what we call a transient term. So we have a transient term here. This would go to 0, so this is transient. And then this is what we call our steady state term. But just some terminology to be aware of, not really something I want to focus on right now. But anyway, that's how we do it.